Greetings, building science enthusiasts, and welcome back to the Building Science Podcast. Today's episode is brought to you by, well, you, actually. We've been reflecting on the podcast, its history, and the incredible feedback that we've received from listeners across the world, and we're absolutely floored by how many of you really care. And it takes a lot of energy and brain power and effort to put this podcast out while we're simultaneously growing positive energy, but we could not be more thrilled about each one of you out there listening and participating in this incredibly important discourse that's so badly needed in our industry. So here's the only thing that we're asking of you. Please take a moment, go to iTunes, and give the podcast a review, and then send the podcast to someone you think might care. Our audience only expands as the reviews come in and more people are out there sharing. You all mean the world to us, and we can't say thank you enough. Enjoy the rest of the episode.
Welcome to the Building Science Podcast. Welcome to the Building Science Podcast.
Bringing the human factor to construction, design, and architecture. Brought to you by Positive Energy in Austin, Texas.
Okay, hello everybody. Hello and welcome back to the Building Science Podcast. I'm Kristof, your host, here with my producer Miguel.
Hello.
As always. And today we are going to be talking again about our mantra, design around people, a good building follows. And we're going to be talking about it from the technology angle, and I'm really pleased to have here in the studio with me Dr. Zoltan Nagy. He's with the School of Engineering, the Civil, Architectural, and Environmental Engineering Department. And he's a professor doing research. And welcome to the program, Zoltan.
Good to be here.
And would you like to talk a little about what you've got going on at your
Sure,
lab?
we can jump right in. One thing we study, or I think the most important thing that we study, is how people perceive space, or how people live in buildings, how they interact with the environment, and in particular how they interact with buildings and building systems. And so we've been just finishing up a study that I think that's quite interesting to your listeners as well, is looking into how building control relates to, let's say, thermal comfort, as two relatively big topics in their own field and being their own fields. But it's quite interesting because we were actually interested in how they relate to each other, because you think when you're controlling a buildings, you do it for the sake of people. But it turns out it's not necessarily the case, and we were intrigued to actually find links or things that are not the same in both fields. So we did this study where we just basically looked at every paper published, that these were in these databases that we looked at, Web of Science.
So you automated that process though, right?
Well, it's actually an interesting story. I when I started, I asked my student to look into this, and we were all excited to look into this. And he goes away and comes back and says, way too many papers. We have like 5,000 papers.
Okay.
But he said, but I have an idea, and let's look at it from a data mining perspective. And then you use text mining to basically, get a quick glance, well, not quick, but a large glance of an overview of these topics. And so that's what we did. We used off-the-shelf programs, and we analyze the abstracts of these papers, and what you get is like nice sort of bubbles of the important words that are happening throughout these 50 plus so years of research in these two fields, and which are important and how they're related to each other, so that you get these images where topics that are close to each other and appear in the same papers are close by. So you get things like thermal comfort is close to ventilation, and then you a little bit farther away you would get materials and envelope and construction.
And so the distances between these two things, so this is like a graph, and the distances between these topics are communicating linkages in these abstracts.
Co-occurrence is correct. So the farther away, the least often these two words would occur in the same document, basically.
Okay.
And so with respect to these two fields, so thermal comfort, relating to people and how they perceive the environment and what makes them feel comfortable, and building control, which is more about energy conservation and optimal use of energy, we find that these two topics are basically in as far away as possible from each other, which was a little shocking.
So we're controlling the system, but not to deliver thermal comfort.
Exactly. So we're controlling, and we're very good at making this very efficient, and being very good at maintaining an efficient system and efficient operating points and things like that. But at the same time, we're somehow neglecting, how people perceive a space.
Yeah. And that's kind of nutty. I mean, as a culture, right? So we're taking our talents and applying them to indoor environments, and our goal as a society is really still centered around energy. And it's like we're forgetting that the energy serves the occupants, and that the occupants want to be healthy and comfortable as much or more than they want to save energy.
Right. And it was a shift. So because we have all the papers, we also looked at it, how these things developed. So
interesting.
So if you go back in history, the first papers, and actually up to the 70s, you had more work from thermal comfort. Very low in general, but more from thermal comfort.
Interesting.
And the first papers in the late 1800s were about comfort, ventilation for disease prevention, right? So that was literally comfort in healthy people and healthy buildings. And then in the 70s, the switch flipped. We started also to understand better thermal comfort, but on the other hand, with the energy crisis, we started to care more about energy. And then all of a sudden, things took off somehow in another direction that, forgot about people or simplified extremely.
Yeah.
So nowadays, what happens is they say, okay, or a typical simplified research paper is to say, okay, we maintain, a constant temperature, we maintain a bandwidth within temperatures that we consider comfortable, and that's it. But we do know since the 70s that that's not true, because, as outdoor conditions change, or how people perceive comfort, or what temperatures they perceive comfortable changes, right?
Mm-hmm.
And that's not necessarily factored in, which seems, we're wasting energy at some point. We're wasting energy maintaining these artificial levels that are not necessarily needed.
Yeah. So this idea of thermo neutrality, right? In the presence of changing outdoor conditions, we just assume, well, if I can just keep the temperature at one constant set point, then my clients will be comfortable, or my occupants will be comfortable. We just assume that, but it's not true.
And that's not even but the worst thing is we know it's not true. So this is not something that we just made up. This has been known for at least 20 years. 15, 20 years for sure.
Mm-hmm.
There's been indications that it's not correct to keep one single temperature point, right? And we know also the factors that play in. We know it's temperature, it's humidity, it's the radiant temperature, so the operating temperature as a combination of the air and the surfaces. We know it's airflow. And so all of these things, acoustics, and then lately also
CO2,
indoor environmental quality.
VOCs, exactly.
So all of these things play a role, but somehow get neglected to simplify things.
Yeah, so we were upstairs before this podcast looking at the radiant heating and cooling system that we have in the ceiling, and one of the things that was striking is that the controllers that are in each room, it's measuring, these controllers are the size of a small thermostat, and getting smaller, by the way. They're measuring mean radiant temperature, they're measuring humidity, and they're measuring CO2. Mm-hmm. So they can control the ventilation system with the CO2 signal. They can calculate the operative temperature based on the MRT and the dry bulb reading. And then, of course, controlling humidity is both for health and comfort. Mm-hmm. And so there's one of those in every room. I mean, we only have 4 rooms up there. And they go to a control system that's going to control everything, the MRT, the operative temperature, the ventilation. Compare that to the typical house, right? One thermostat.
Right, one thermostat fits all, yes. So that's probably not the case.
Yeah. So controls, that's an interesting, it's a topic that can just go on and on different directions. But where we want to take the conversation today is controls from the perspective of serving health and comfort. And let's start out the conversation with like a new construction or a substantial remodel. Mm-hmm. So in the domain of new construction, almost every manufacturer out there now has a control system that can be controlled by an internet connected device. So we've entered the realm of the Internet of Things. And as we do so, the opportunity to have different control paradigms and different ways for the occupants to engage with the controls increase. So typically we have a situation where the thermostat is dumb and the occupant tells it, keep me at this temperature. Have you done studies where you looked at the control system thinking on its own?
So what we did, or the way I approached this, because maybe also just as a little background about myself, I did not study building, or I'm not from the building field. I studied mechanical engineering, and I studied robotics and intelligent systems, and I spent a couple of years after my PhD in architecture and building systems in the Department of Architecture in Zurich. And that gives me another perspective on things, so I'm not stuck in a way in old thinking. At least that's how I like to think about things.
I agree. Outsiders sometimes have...
Yeah, and so what we did, or what we tried to think is, yes, this idea of everybody likes the same set point is nonsense, and nobody knows what the set points would be because everybody's different. And at the time, what we could do is experiment with this with lighting, because we had access to the lighting system. It was easy to install lighting monitors, light level sensors, so we monitored minute levels of light in about 10 offices that we had. This is in Zurich. We could also see when the lights were on. We could see when the people would switch on the lights. It's an office building. And the offices were distributed across, south and I think north and east a few, west and east a few. So there were different, settings. There were different people. There were different, like some were single people offices, some were double, some were more people, and so we had a variety of things. And we asked this question, does it make sense to control to single set point? So we switched the problem the other way and said, well, what happens in the office first of all? So what we did is just to monitor for a while. Okay, what are the light levels? When do people switch on the lights? And so every time somebody would turn on the lights, we would mark it. So we'd say, okay, right before that, what was the light level? And then after a while, obviously 2-3 weeks, you'd have a certain distribution of, when people switch the lights on. So you can infer some kind of preference. And then we started turning the lights on. So then we say, okay, now we have an average of when people like the lights on, turn them on. And then when they're gone, switch the lights off. And then after, we did a couple of studies like this, but we were always the same thing. You could see every office behaves differently, which is proving the same thing, that everybody's different. And beyond that, the light levels that would be in the code actually were much higher than the people liked them.
Interesting.
So you just by that you would save energy, because there was no need to keep it as high as the code would prescribe it, even though that's also a healthy issue. So there is a discussion here. But it was interesting to see that some people actually switched off the automatic control. So we allowed that in the system. We could say, okay, if you don't like it, switch it off. We gave them at some point different interaction features, so they could use the light switch that was on the wall, so nothing changed for them. Or they could use a web interface where they could actually put in their light level preference, or switch the light on from the desk, just to see if that would be used. That was not used, which also confirms my second idea that all these smart devices and apps, it's a toy, but it will not really take off because it takes too much to deal with it, and it does not add much of.
Yeah, there's people like it at first because it's new and different and exciting, but I mean this has been shown with being able to do in real time monitor the power that you're using in your home. People would change their behavior for a while.
And then it stops.
But getting back to your control thing, so you were controlling lights, and you ascertained the levels at which people turn the lights on, and you're able to automate that by just observing the people and saying, okay, so you have these preferences. So if we take that over into mechanical systems, so heating, ventilation, air conditioning, it's interesting. It splits up because you can definitely start to anticipate a given occupant's preference in a given building or a given home for thermal comfort. But for health, the occupant is not the best sensor, right? I'm probably breathing PM 2.5 right now, unaware.
Right.
So you need a different set of sensors. You kind of need two systems.
Right. I mean, health is a different issue because that's not that we don't talk about comfort anymore. There we talk about providing basic means of ventilation and health prevention, and that becomes more and more of an issue if you start sealing off your envelopes. So the more insulation you put to lower your energy bill, the more the less ventilation you have through the walls, which increases.
Well, that ship has sailed in some sense. Or, I'm sorry, not even some sense. That ship has sailed, right? We are required, and we as a culture have decided we're going to conserve energy by making enclosures more functional. Right. And that means that we as a culture have now decided that we're going to have mechanical ventilation, but we're just realizing that.
In the U.S., that's true. In Europe, that's not true. So they're still in that boat where you add insulation to lower your heating bills, because that's what we do more or less there. There is no necessarily air conditioning in homes is not prevalent.
It's radiant systems and
it's
windows
radiators,
or ventilation.
Yeah, ventilation and radiators and windows. And so what happens is you add insulation and your rooms start to overheat, and you have another problem. And then you're stuck because the buildings don't breathe anymore. So that's what's happening there.
So Northern European.
Yeah.
Okay, but let's stay with that. So let's stay with thermal comfort in buildings, and let's stay in America because that's where we are right now. So and let's stay right where we are. To Austin, Texas. Yes. It's hot and humid, so we need to deal with the heat and the humidity in our buildings. So you could have a sensor suite. It would need to be based on relative humidity and temperature in the building.
Absolutely.
But then, with these internet-based sensors, we could be monitoring space conditions and anticipating an owner's needs. And what would be the ways that would interact with privacy? Let's just touch on that one.
Well, privacy is an interesting and important topic because, or at some point, especially if you talk about internet-connected devices and cloud computing, obviously your data goes somewhere, and whatever you may like it or not, you could use it for the good or the bad, just like with anything. And so I mean I think so. While it's not my expertise or to deal with privacy issues when it comes to data, I think it's just some topic that we will either just accept as a society, or somebody will find an acceptable solution. I mean, right now we put on our Facebook where we are, basically inviting burglars to tell them we're not at home, and that's that's a more serious breach of privacy than your temperature sensor data. So the whole thing with privacy is, what am I getting out of it versus what am I losing? And I think that one of the issues is that, especially in the home or residential thermal systems, mechanical systems environment, you do not see actually an added value on all of these things, right? That's the main issue. You have your thermostat, you're cold enough. Why do you need to add stuff on that? I think that's the main point. So soon as you get something where you say, okay, this really is helpful to me, then the privacy questions will become different.
And so if I have a decentralized cloud-based control system for my indoor environment at my home, can you anticipate a large value add for the average homeowner based on that?
Yeah, I think there are issues where we can. So if you can control, at least, let's say utility can control a large amount of thermostats, like Austin Energy does in a buying basis, right? You can obviously, especially in the peak loads in the summer here, you can lower your energy bill, but also make your infrastructure more resilient because you don't have the peaks, you don't have blackouts and so on. So that's the main. So that's a societal thing.
It's not necessarily a personal benefit.
It's not a personal benefit, right? So on a personal level, it's the question of whether that adds you comfort or not, and it's probably not. You will only feel it in your pocket, in your wallet. So if it saves you money, you will do it. If it not, you won't. Right now, there is no incentives to save energy in a home, I think.
Right. So what about if we go? What if we make the cloud computing that much more intelligent by, instead of trying to anticipate patterns and preferences, which is one level, what if I have, like Miguel has an iWatch. Is that what it's called, or an Apple Watch? He has an Apple Watch. Excuse me, ghost of Steve Jobs. So his Apple Watch could start to measure, pulse and galvanic skin temperature and all these different things, and monitor in real time sort of this comfort biometric signal.
Mm.
So I could send that to the cloud, and I wouldn't even have to guess. I'd say he's uncomfortable right now, or he's in an area where he typically gets uncomfortable.
Right. So I think where we're touching with that is healthcare. So that's one where. So when you start, linking in with your doctors, linking in with, healthcare is a huge issue, right? Not just how it works, but everything.
Yeah.
And so once the home comfort and the home environment becomes related to a healthcare, and then you connect it to your doctors and say, well, I'm feeling bad, I have asthma issues or whatever. Well, and he looks at your data and says, well, yeah, of course, you have something in your house that's not good for you. And so these kind of added values on a systemic level might be also something that drive.
Fascinating. So healthcare in the home occurring in real time over cloud-based biometrics.
Yeah, and we've seen a lot of the discussion writ large kind of shift towards people thinking about healthy homes. Kind of what you were touching on earlier. And energy efficiency is not much of the primary concern that homeowners have anymore.
Right.
And I think there's still a huge educational gap and disparity that we still have to overcome. But people are much more apt to spend money when they think that it might make them healthier than they might save a little money on their electric bill.
Right.
Which is kind of a reversal of kind of the assumption that was made throughout most of the 2000s.
Absolutely. Yeah, and even taking that out of the home into the business aspect, when we're all in our offices here, right? So as a business owner, you guys are the biggest expense we have, right?
Sorry.
My human capital. No, you're worth double what you're getting. But let's say, you can imagine a conference room filled with C-level executives, and, that there's a lot of intellectual capital. That is the kind of the engine of the company in terms of ideas and leadership. Well, they're in that conference room, and the CO2 is 1,300 parts per million, so I've constrained or I've impaired their cognitive function.
Right.
And so the business owner is not realizing, their office, their conference room, is actually a very expensive liability.
Yeah, that's the other thing that comes back to people and working with people and not for the energy, is that if you look at commercial buildings, banks, and so on, then your most expensive things are the people in there, right? So your
So let's
biggest.
take care of them.
So so why not focus on that? And energy is such a small part in general in reality that if people are happy and productive, you will actually see the benefit of it rather than trying to save a few bucks and keep everybody cold, or in a too much of a CO2 environment.
Right. So actually, you are with CAEE, so Civil, Architectural, and Environmental Engineering. And architectural engineering is the side of architecture that's really thinking about the functionality, right? The engineering practices of the building. Architecture as a practice right now is wanting to be more concerned with visual, spatial, and less with the function.
At least on the custom residential scale. And then the other problem is sort of at the developer-driven scale. It's like first cost, whatever we can just put up and get our money back quickly on.
Right.
Yeah, so I guess I'm curious, at UT, there's the School of Architecture, and there's the School of Engineering, which has architectural engineering in it. Are they talking to each other?
Yeah, it's a good question, yeah. Yes, of course we're talking to each other. We have, next semester, I think, we have actually the capstone projects of both schools as one major project.
Fantastic.
So that's going to be a big push. We're also, my wife's a faculty in the School of Architecture. As
Interesting,
a matter of fact,
I didn't know that.
Teaches building environmental controls for architects. So next, we will also, and I teach the same for the architecture engineers next semester.
Interesting.
So currently, we'll plan to put these also in like one sort of project together. So we'll have both sides in one. Because the major issue is communication, and once you're out of school, it goes off too quickly in the two directions. So while we have them in one location, so to speak, we have to at least make them speak to each other.
Yeah.
I think it's interesting that on campus we're also pretty far apart from each other now. It's dealing with buildings. Geographically, it's also, it couldn't almost not be farther.
Oh no.
It's kind of an interesting metaphor for the sensors, right?
That's what I meant, yeah.
Yeah.
So the idea of, you came out of robotics and engineering, and now you're studying buildings. I think that's fantastic. Buildings as functional systems, because ultimately a home needs to, one of the most important thing a home delivers to society is a healthy human being that's ready to engage and produce value and save the world. If I go home every night and I breathe bad particles and I have moisture in my walls and I'm on Zyrtec all the time, and it's not helping anybody. The costs just ripple out. But when it comes to your work right now, you're starting to shift it over into the health in buildings or thermal comfort in buildings.
Right. I mean,
where do you see it going?
Yeah. I mean, I mentioned the lighting study, but the only reason we did lighting is because we had that setup there, so I didn't need to do any ramp up, and it just worked out of the box with little modifications. What we do now here at UT is we actually do thermal comfort. So we're preparing an experiment in one of the UT campus buildings where we will do a similar study, but we'll do thermal comfort. So it will be 20, 40 offices. It will be the thermal environment. It will be radiant. We'll measure radiant, hopefully, if we can get it to work, and then thermal temperature, humidity, outdoor conditions, and then also ask people how they feel. And so then we can afterwards create a system where it links back into their building management systems, and then actually act on it. So we see now we're monitoring the set points, we monitor the equipment, and then we will try to create, pattern recognition system where then can say, okay, this is what people like, or that particular person likes, make it useful for them.
But there's no health in that per se. And you're interviewing the person.
No, that's correct. So right now, there is no health in it. So we're not focusing on that in particular. I'm looking at thermal in the beginning, and then in the next steps later on might be eventually health. But the point I was making before is that health is a minimum. So you need to say that's something that actually physicians need to study and say, okay, in these environments we need to, that's a healthy environment, or that's when it becomes dangerous.
Yeah.
It's not so much about asking people, do you feel sick or not, right? So that's the occupant-centered approach breaks down at that point.
Right.
I can ask you if you feel hot or cold, and you will feel colder than somebody else, but if you're in a lot of CO2 and you're just sleeping, we know those things already. So what we need to do there is just install the sensors, write the monitors, and create alarms. And that's a cost issue. It's not a... We know those things, right?
But developing the pattern recognition sort of intellectual property is really important to kind of moving that forward, right?
Right, so developing that, and the interesting thing about buildings, when you think about it, or at least that strikes me as interesting, is that every building is different, right? So now you can say every person is different in a building, but take two people into the same building, they will act differently, and then take the same person into different buildings, it will again have, different implications. And dealing with these kind of differences, and if you go into residential, it's even worse, because then literally different people with different buildings. And so now how do you find a method that scales up to a large amount of buildings and can adapt to people is where pattern recognition and artificial intelligence is, I think, the way to go. And that's different to, let's say, self-driving cars. It's different from airplanes, the classical engineering domains where you have so many that it makes sense to create mathematical models and everything is the same and you can just optimize those and let them go and, build them. Buildings are a mess, literally. Right?
So you're dealing with inconsistent data.
You're dealing with no data, bad data, old data. I mean, the lifetime of a building, 50, 70 years, systems have been changed, things have been added, people have moved. Yeah. You don't know what's going on, so
the mathematics for that are
so you don't get to do a deterministic model, but you do have the ability to have an adaptive model that it is trying to control and keep environmental conditions in certain ranges.
Right.
Could that extend out? We remember early on in this podcast we stopped talking about existing buildings and retrofits.
Mm-hmm.
If you had that adaptive control network and you had sensors in the building, then you could really start to address, well, if you had systems too, you could really start to address indoor air quality in homes and thermal comfort in existing buildings.
Right.
The typical Austin home, 1970s, 1980s home, it needs some help before you can really just change the performance of the systems to deliver health and comfort, right? You need to do duct sealing, almost for sure, and add an effective ventilation system, right? And point source exhaust system. So, and a dehumidifier.
There are many things. I mean, but in at different levels you can do different things, right? I mean, if you just exchange your HVAC compressor or whatever, you will already improve the system, right? And even if you don't do anything on the house itself, and then you can do the ducting and so on. You can also go on the controls and say, okay, we'll do that part. I mean, it's there are very many low-hanging fruits that are not necessarily considered because people don't realize it, right?
Yeah,
you don't know that your AC is not working or wasting energy.
Or
you just see your
lungs.
bill or polluting your lungs.
Yeah.
You just see that you're, you see your energy bill, but you're cold, so you go, thank you, right? Once you're not cold, it's not working. You call the guy, he patches up, and then it continues, right? But there is no continuous monitoring, and that's again where you might get added value with the Internet of Things if they are, if you create startups or business models around this idea that, okay, we're just gonna, grab the data off your AC and we're just gonna watch it, 15-minute data, whatever, of all the components that are somewhat doing something, and we'll tell you how much better it could be, right? Those are the questions that you could do without updating the house necessarily.
Yeah.
But the system is not working. Those things you don't see until you start, but you could detect them with the data. Especially if that particular startup or company or whatever has many data. Because like you said, you have many, not the same, but similar buildings with similar kind of systems. So if you have outliers in there, or something that doesn't fit the pattern, you will see it, right?
Yeah. Well, that's an interesting perspective too. The data, who owns the data? Michael Blasnick, at least he used to be with Nest, Blasnick and Associates. Amazing amount of data coming out of Nest thermostats, and the amount of insights and preference behavior data that's embedded in that is just profound. And he presents regularly, and it's just fascinating. But it's interesting. There's always this point in the presentation where people ask questions, and he's like, "Well, I can't just give you my data file.
Yeah,
it's private, and it belongs to, I guess, Google."
Well, is it Google or is it the person, right? That is the question.
Why? It's a question.
And that's again now. If that thermostat provides me the added value, that it's worth it for me to share my data, then it's another story. Right now, I don't know if it does. I would question that. But maybe at some point it will be that your HVAC guy knocks at your door and says, well, wait a minute, we saw that your AC is not working. And you're like, how did you know? Well, we have access, so these kind of questions will come. And then the question again, back to privacy, who is owning the data? And, do you agree by using the Nest thermostat to these kind of things?
It's a very complicated ethics.
That's beyond the scope of building science.
It is.
However, it does seem that at the most coarse level, the data is intended to accomplish the sensor that is sourcing the data is intended to serve the occupant. And so the downstream from the sensor is the data, so the data should serve the occupant, which means it should be the occupant's discretion on how it gets used and who gets it and who owns it. But currently it's not. Is that right? I mean,
I'm not...
Can you get Nest data? Can anyone get Nest data off their thermostat?
So you can get your own Nest data, but I think that you're not allowed to save it.
Interesting.
I think that's how it is currently, but I might be wrong.
Screenshots only?
There is an API, so you can build APIs made for companies to build apps onto Nest. I think I'm not a Nest expert, so this might be all a little bit off.
Okay.
But you can actually, but the access goes through the internet, so your Nest has to be on the Wi-Fi or whatever, and then you can log into it and get your data off, and you see when you change your set points, what the current set points are. You can change it, so But I think the API forbids you from saving the data long term, if I'm correct. the same analogy is though with Gmail. I mean, you have Gmail is free, right? Tons of data. It's free email. What you get out of it is, you don't need to pay for email. What you pay for it is, banner ads and targeted ads and so on. So we're already living in this world. This just extends from the digital into the physical world somehow. That's this link, right?
Yeah.
And the other link is security. So we talked about healthcare. The other part is security, where Nest is also having a security camera and security thing, and all the smart home companies or features from Samsung or Panasonic, Philips, are having safety features, which is there where they see the value added, not so much in the energy of the buildings.
Fascinating. Yeah, it reminds me, what was it? Tom Cruise in a movie called Minority Report. In the beginning of that movie, or during that movie, it's like these targeted commercials as he's walking around. The future is here now. I mean, that's happening now.
We're almost there,
Yeah, and yet here we are, living in the future, and our homes and buildings are still very gradually catching up to us. I don't know. We're not the experts on it, but why do you think that is? I mean, just
there's a big inertia in the buildings, right? So because buildings have such a long time span that you're not used to changing things quickly.
Interesting, yeah.
I think it's
and the industry that delivers buildings
is likewise slow, right?
It's set up to be slow.
I mean, if you compare buildings industry to cars or airplanes, you would probably not set yourself into a car that was built in the 1970s anymore, and yet your house is built in the 1970s, and your systems have been updated 10 years ago, but your car, probably you would not drive a car at that standards the way, you accept your house.
Yeah.
Same with, the light switches and so on. I mean, there's, there are easier ways or better ways, or there's just, the inertia in changing things in buildings is just much, much larger, I think, and that's just the way it is. I think.
And the cars is a great one. It's kind of like in cars, they've gotten so much better, and they continue to evolve. I mean, AI is coming into there strong, but homes, we assume they're fine, right? That's the thing. And our sensors are fairly coarse, especially when it comes to health sensors. So there's this implicit assumption that there's really nothing needed to be fixed, but that's wrong.
Yeah, I mean, house is not a consumer product. You don't exchange it every few years, right? Like you do with a car. And so, and you don't know. It's been always like that. You got used to it, and once you get used to it, you don't really know that something's wrong. Only if you're out of it for a very long time, and then you go back, you will realize, right?
Yeah.
That's
so
the issue.
The reason this is interesting in the context of controls and the Internet of Things, and almost thinking of adaptive systems, like the house becomes a robot to serve my lifestyle. All that's ready to happen. We just need to have society say, "Hey, I'm interested in that happening," and it's a push-pull situation. Right?
It's happening. The technology is there. You see it everywhere. Like all these companies coming with the smart home solutions. The cell phones did a big push to get these gadgets work for you. But I think we're circling back to the beginning of when we talked about value. So where is the killer app, so to speak? Where is the big thing?
Yeah, home dashboards never worked, or haven't.
Home dashboards never worked. Is it now the home interface, the Google Speak or whatever it's called, Google Home or Alexa or Apple? It's like, is that it, right? Where you can just speak and that will then turn on your TV and run your Netflix and then move your thermostat. And is that it or not? And how much is that actually part of the health again? So we're circling back to that again. Can we get somehow, what if insurance companies said, if you let us monitor your environment, we'll give you a break on your
health insurance.
Health insurance, I mean, these things, now that the technology is there, I think the business side needs to be worked out.
Oh, and vice versa, though. If we monitor your environment and you're smoking all the time, we're going to raise your rates.
Exactly.
Interesting. Or you bought that carpet padding with phthalates in it.
Your house is off-gassing stuff. It's normal that you're sick.
We're going to raise your health insurance rate. That's fascinating.
Well, whether it's ethical or not, it's another question. The point is that it's the technology is there, and the regulators are in need to put in place things to deal with privacy. Who gets the data? Because health data is much more sensitive than energy data. And so that's going to be a big question, I think, for the coming 10 years or so.
Mm-hmm. Okay, so we're getting towards the end here. So controls and sensors are undoubtedly in the process of proliferating. Or let me say it more accurately. Sensors are undoubtedly in the process of proliferating.
Right.
And this expands the opportunity for different control regimes. And you're interested in looking at adaptive and self-learning based controls, is that right?
Right.
And you're thinking about it from the thermal comfort perspective and
so for me,
the health perspective.
Yeah, the health, I think it encompasses all of it. So when you think about the fact that, like we said before, you need people, so the systems are, unique. So that's one thing you have to deal with. And people are unique. That's another thing you have to deal with. And that's when...
The buildings are unique.
Buildings are unique. Everything is unique. Everything is a prototype. And that's why you need adaptive systems, right? And so we work with what is called reinforcement learning approaches. And that's basically the fact that you don't have models, but you try to get to your best solution through interaction. And so whether that is strictly on the system, where the system does something, observes what happens, takes note, improves over time, or literally the person giving some kind of feedback, saying, okay, I like this, I don't like this.
Those are rules, right?
No, this is feedback. So
that's feedback.
Literally, okay, so for example, the simple one is the light goes on for whatever reason, person goes back, turns it off, then the system knows, okay, didn't like that for this, this environment, this was a bad decision, I will not do that anymore.
I see.
So you can teach your house at some point, like the way you teach a dog.
Mm-hmm,
You say, okay, I like this, I don't like this, and over time you can adapt. The house will adapt to the people will adapt to the house. There is a dual thing here going on. And the same with the systems. And what I like about this approach is that it's scalable because, everything is different, so you can just deploy it everywhere, basically, and it should work.
And it learns its new adaptive rules.
Hopefully it works, and it's made to deal with people. So it's, the framework is this interaction. So if you create a system where you can get the interaction or the feedback from the people directly, then you win. And it has to be natural and not some, app where you have to zip through 5 menu points to set some kind of temperature. But it needs to be simple.
Yeah.
That's that.
So that last topic, so Internet of Things versus simplicity, right? So Internet of Things, it's weird, Zoltán. It's like it goes both ways. It seems to make things very simple. You don't do anything. The system learns on its own. It's thinking for you. Yet it relies on power and the internet and an internet connection. And so how would you evaluate the Internet of Things versus keeping things as simple as possible but no simpler?
I think that's an interesting question. I think in many ways those are not exclusive. The idea is that Internet of Things will make things simpler because you're always connected and you're always on, so to speak, ideally.
Mm-hmm.
And the fact that you're connecting through the internet also helps it to be decentralized. So you don't need this one node or center brain in your home that takes care of everything, where everything connects to, but you can add and remove nodes as you go, basically, and it will still work for you.
Mm-hmm.
And in a way that's simple because it's resilient or robust.
Right.
And so that's why I think that will be an interesting approach in the future. And whether that actually you don't have to go directly through the internet. You can have these with the other protocols that exist. Whether you just do it in your own house through Wi-Fi, whether you do it over a Zigbee network or the Bluetooth networks that exist, those all work, provided you have power, of course, till the time that you need.
And I think you can assume power, yeah.
Yeah.
But so you're saying the control system could be in the house and not out there on the cloud.
Right, absolutely. So when we say it's AI or the self-learning things, it does not have to connect anywhere. I mean, you can have that in your home and that's it. And then you just do it there.
Interesting.
Right.
Okay. So what you're making me reminded of is the reality that today, having an internet signal everywhere is just starting to become like, oh, of course, pretty much everywhere. If you find yourself somewhere without, you can't get to the internet, it's maybe a relief, actually. That's why people go camping or something now. But it's like, so we have a building in downtown Austin here, and it's going to have electricity utility, it's going to have natural gas, and it's going to have a sewer line, and it's going to have water supply. And we think of that as completely normal, that we have those services of energy flows. And it's also going to have an information source, right? So we need to realize that this flow of information to and from our buildings and in and out of our brains, in and out of the internet, in and out of our brain, is in fact like a new utility.
It is, yes.
And we can leverage it to do many, many different functions. And one of them is to take professors like you and add value to society.
Hopefully.
Hopefully, yeah. Yeah, that is probably a good place to wrap up. It should be as simple as possible, but simpler.
Not simpler.
All right, well, thank you very much for spending the time talking with us.
Thanks for having me.
That's it, you guys. We'll be back next time. Appreciate you listening.